First of all, thank you very much for attending this session. My name is Graf and today I would like to present the Predictive Corridor, which is a virtual augmented driving assistance system for teleoperated autonomous vehicle. I will start this presentation with a few motivations, then I will explain the approach to how we developed the Predictive Corridor, how we evaluated it, and finally I will close the presentation with a few remarks. But let's start with the motivation. Autonomous vehicles offer a driverless future. However, despite rapid progress in sensory technology, human situation assessment continues to be required. For example, upon recognizing an obstacle on the road, a request might be routed to a teleoperator who can assess and manage the situation with the help of a dedicated workspace. Inevitably, teleoperation must face several challenges. For instance, high latency and low remote situation awareness. To address these challenges, prior works had proposed remote driver assistance system for vehicle teleoperation. For example, the predictive display. The predictive display, as the name implies, predicts the movement of the remote vehicle and the movement of other road users to forecast the vehicle position and to overcome the time delay. The prediction of the remote vehicle is shown to the teleoperator as an overlay on the video images. Previous research has shown that it's highly effectively. However, most recent development in trajectory prediction required a closed-loop analysis and evaluation in terms of cognitive workload for the teleoperator. Another HMI example is the free corridor. In the free corridor, a path of full braking is shown to the teleoperator. The vehicle would follow the predetermined trajectory and stop if no further connection is available between the operator and the workstation. An open-loop evaluation of this concept has been provided. However, investigation on the cognitive workload of the teleoperator is needed. Therefore, on the one hand, we see that the free corridor provides a solution in case of communication losses are available. Yet it does not address the problem with the time latency. On the other hand, the predictive display allows to overcome the time latency, but no emergency concept is provided in situation of communication failure. A combination of both concept would benefit the teleoperator since strategies to mitigate the time delay and the required emergency concept will be present. In this paper, we explore exactly this opportunity. Our approach. We started developing the predictive display and the free corridor and combined them into a single virtual augmented element that we called predictive corridor. The predictive corridor shows the predicted position to the remote operator and the vehicle braking position. This means that the free corridor does not begin at the current vehicle position, but at the end of the predictive display. We develop and integrate the predictive corridor into Spider, which is a software programming interface for distributed real-time driving simulation. To emulate the communication delay, we set a simplified constant latency in the loop. This approach provides a fluid video streaming for the teleoperator, as inconsistency latency might be more harmful than longer fixed one, as show recent publications. Thus, the control loop is affected of 200 milliseconds in one way and 200 millisecond delay in the other way. So from and to the vehicle, we have 400 milliseconds in total. This means that we calculate the length of the predictive corridor as follows. Time reaction, which consider the reaction time to trigger the braking pedals to be 150 milliseconds, and the total time latency of the control loop is 400 milliseconds. Therefore, we consider the total length of the predictive corridor to be 515 milliseconds. To evaluate the predictive corridor, we designed a user study. Our main research question was, does the predictive corridor improve the teleoperator user experience? And in particular, how will the predictive corridor influence the cognitive load, visual attention, performance of the teleoperator? Our hypotheses were the predictive corridor will reduce the teleoperator cognitive load, will not affect the teleoperator visual attention, and reduce the teleoperator errors. Procedure. To answer our research hypothesis, we used a within-subject study design. The whole study lasted about 45 minutes. Upon arrival, participants were welcomed and asked to sign a consent and demographic form, and they're informed also about the aim of the study. Then we asked the participant to relax 5 minutes for sensing and calibrate the thermal camera. This allowed us to collect their physiological data in a state of relaxation. In the second part of the study, we introduced the prototype as well as the driving simulator and let the participant familiarize with the steering wheel and pedals, and also with the time delay. After the practice session, we administered 2 tasks, lane change and emergency braking stop, both with and without the predictive corridor. After each session, we administered the NASA-TLX questionnaire to assess the perceived cognitive workload. Our apparatus. Our experimental setup consisted of one compact infrared thermal camera that was installed on a tripod beyond 3-screen monitor where the participant received the virtual environment. The screen were 23-inch big wide. To be able to record the X and Y coordinate of the participant gaze, we attached in the middle screen, in the middle monitor, a commercial eye tracker. A steering wheel with relative pedals was also installed to control the vehicle. Lastly, one computer enabled the communication of input and output signals between the simulator and the automotive control elements, which in other words are the steering wheel and the pedals. The task. To evaluate the prototype, 2 test courses were designed. The scenario were inspired by the U.S. National Highway Traffic Safety Administration report. First, we administered the emergency braking stop, which is a straight line of 15 meters. The second test course is simulate a lane change maneuver. Both test courses were intended to experience a longitudinal and lateral control of the vehicle under clear weather condition in daylight with a posted speed limit of 15 km per hour. Also, since teleoperating involves controlling a vehicle under some time latency, in this study we simulated a constant time delay of 400 milliseconds. This was suggested as prior research has shown that constant latency is easier to manage than a variable one. Lastly, the participant gas and brake pedal were manipulated to have a constant linear acceleration as well as deceleration from each subject. Now some result. In this work, we analyzed the effect of using the predicted corridor on the forehead nasal temperature as indicator of the experienced cognitive load. During the lane change task, on average, participant forehead nasal temperature decreased when performing with the predictive corridor. The t-test showed this to be significant. Similarly happened during the emergency braking stop task. These results have been also confirmed by the subjective assessment of cognitive load reported by the participant. In fact, according to the NASA-TLX rating scale, on average, participants experience less workload when performing with the predictive corridor. The t-test also here show this decrease to be significant. These outcomes indicate clearly that the user experienced less cognitive load when performing with the predictive corridor. For the second hypothesis concerning the visual attention, we investigated the gaze point falling in the predictive corridor area. On the lane change maneuver, as well as in the emergency braking task, the t-test didn't show any statistical significance, as the difference between the gaze data distribution and the length of the fixation in both conditions are almost equal. This could indicate that adding the predictive corridor changed the effect of the gaze behavior. However, it does not correlate to increasing on visual attention in the area of the predictive corridor. So now some results about the performances. The performance of the lane change maneuver were tested by counting and comparing the number of cone collisions. On average, participants hit fewer cones when performing with the predictive corridor. The t-test showed this decrease to be significant. A linear regression was calculated to predict the number of cone collisions based on the number of trials, and a significant regression equation was found for performing with and without the predictive corridor. These results suggest that the presence of the predictive corridor caused fewer collisions, and the linear regression analysis reveals also that a faster negative flow of the data point was recorded when performing with the predictive corridor. These results are advising evidence in favor of the predictive corridor. On the emergency braking stop task, we calculated the distance to the stop line as relevant information to conduct our analysis. On average, participants stopped closer to the stop line when performing without the predictive corridor. What does it mean? That means that the analysis showed that without the presence of the predictive corridor, participants tended to shorten the distance to the stop line by each trials, which did not happen when we show the predictive corridor. Keeping the right distance is essential to prevent a collision and to react accordingly to dynamic object in the street. And these results have been also confirmed by the linear regression analysis, and we found both equations to be significant. Now, some conclusion. We evaluate the predictive display and present a novel statistical analysis on the combination of the predictive display and free corridor. The evaluation was conducted by employing novel objective technique as thermography for assessment of workload. We compared this with classical subjective technique as NASA-TLX. For the evaluation of the locus of attention was conducted by analyzing the participant case data. And finally, we assessed participant performance on both test courses, that is the lane change and the emergency braking stop task. Overall, behavioral analysis as well as subjective and objective evaluation method for assessment of workload show evidence in favor of the predictive corridor. However, to confirm our hypothesis, we suggest further evaluation that consider dynamic object as well. Thank you for your attention.